Hello everyone, welcome to our class. Now let's study chapter 7, the state function of practical gas. Firstly, we discuss the behavior of perfect gas. As we know, real gas consists of a large number of molecules. Each molecule is moving with kinetic energy. The molecules have affect each other with potential energy. However, under some conditions, the gas can be simplified. 1. The molecule can be considered a point without volume. The second, no force between molecules. When high temperature and low pressure, the first assumption is similar. And when the specific volume is very big, the specific volume is very big, the second assumption also is similar. So if satisfying the conditions, these two conditions, it can be called perfect gas. Also, sometimes we can call it ideal gas. Okay, in 1840, Clapeyron proposed the state function of ideal gas. It is very famous function. PV equals RGT. P is pressure, V is specific volume, RG is universe the constant, T is temperature. Okay, the first section, van der Waals equation. In 1873, van der Waals proposed a practical gas equation. P equals Rg over V minus B minus A over V power second. This equation also is very famous. He thought molecules of a practical gas occupy the volume so that moving space of molecules is reduced, so that the specific volume of the gas become V ideal equals V minus B, become smaller. The state equation become P equals Rg over V minus B. Here, B is an empiric constant. On the other hand, when the distance between molecules is larger, because the distance between the molecules is larger, there will be molecules attraction. Between the molecules, there is some attraction. Molecules will have together potential. There is some attraction. The distance is inversely proportional to the V power second. Therefore, the pressure of practical gas is less than that of the ideal gas. The pressure becomes smaller. The ideal gas, the pressure is larger. So P ideal equals P plus A over V power second. So together, two conditions. Finally, practical gas function is written as follows. So become P plus V over V power second times V minus B equals RGT. There is some changeable. There's some change from the ideal gas, for ideal gas equation. So we can write again P equals RGT over V minus B, also minus A over V power second, where A and B is two constants. We can obtain A and B from some experiment. So it is empiric constant. Van der Waals equation is very famous from that time. P plus A over V power second times V minus B equals RGT. It is first modified equation for ideal gas. Each term has clear physical meaning. It can give very good results when the gas is not so far away from the perfect gas. It's close to the perfect gas. Is very good. Can obtain very good the result. Okay, Van der Waals equation can be modified further as here is modified the equation. P equals RGT over V minus B, also minus A over V power second plus UBV and plus VB power second become complex, become longer. This equation includes 4 constants. UBW is constant. A is temperature function. This equation can get more accurate values, become good. Obviously, become more complex, more difficult to calculate. When A equals B equals 0, Van der Waals equation tends to ideal gas equation. We can find if A and B is 0, just is ideal gas equation. Okay, here we give some discuss about the Van der Waals equation. If Van der Waals equation is right at critical point, because we know any gas, any substance, there is some critical point. In this case, we can instituting the critical point parameters into Van der Waals equation. In this case, we can obtain partial P, partial V at Tc. In this case, this differential certainly equals 0. We substitute the parameters into the Van der Waals equation. We obtain one equation. Also, partial P power second, partial V power second at Tc, also we obtain another equation. Solve these 2 equations with Van der Waals equation together. At critical point, we can get 3 equations. We can calculate Vc, Tc, Pc. If we understand Vc, Tc, and Pc, we can calculate BAR together. We can obtain the 3 constants. That's to say, we can use critical point parameters to calculate the constant A and B, include R. Thank you.